welcome to our Geo for Good Lightning Talk series. This month marks our third round, and the theme this month is nature conservation. My name is Tanya. I'm a program manager on the Google Earth Outreach team. Earlier this year, we started a series of monthly lightning talks by and for nonprofits, scientists, and other change makers who want to leverage mapping tools and technology for positive impact in the world. We hope these talks will inspire you to think of new ways you can have an impact with mapping tools or provide operational or practical hints to improve and optimize your workflows. I'm very excited to welcome this month's speakers. Alanna Rebelo from Stellenbosch University in South Africa, who's mapping invasive trees and quantifying ecosystem services. Amanda Stahl, who analyzes site-specific and large-scale landscapes at Washington State University. Matt Hepler of Appalachian Voices, whose work monitors restoration at coal mining sites in the US. Tanushree Biswas at the Nature Conservancy, who works on nature's role in reducing our climate impact. Laura Poggio at ISRIC, World Soil Information, who works on digital soil mapping. Hi, Laura. And finally, Dan Dixon, who researches landscape drivers of eucalypt forest phenology at the University of Western Australia. Hi, Dan.
Hello.
Okay, before we kick off our first presentation, I would like to call your attention to two things. First is the Q&A feature. If you're watching live, you can write your question in the Q&A section below this page. If you have a specific question to any speaker, please identify which speaker you want to ask a question of, and then write your question in the Q&A section. The second is the link to the slides, which you can find below in the resource section. All right, let's begin. Alanna Rebelo is a postdoc in the Conservation, Ecology, and Entomology department at Stellenbosch University in South Africa. Alanna's research focus is generally around trying to quantify the benefits of healthy ecosystem for people using a combination of applied remote sensing techniques, ecosystem service quantification, field measurements, and eco-hydrological modeling. She's also going to share why she's passionate about leveraging the free platforms and satellite imagery to boost nature conservation efforts in data and resource-scarce regions. Let's hear her talk.
Today, I'm going to be talking about mapping invasive alien trees in data-scarce regions. And I've titled my talk, If It's Green, It's Good. So does this picture on the right-hand side look like a healthy ecosystem to you? There's lush green pine trees covering a mountain landscape. Well, in fact, these trees are invasive alien trees that are invading the fynbos biome. So to put this in context, I want to do a little introduction to two African ecosystems. This is fynbos. It's a very biodiverse Mediterranean shrubland that occurs at the tip of Africa. And what you might notice from this picture is that trees are conspicuously absent. In this second shot is grassland in the foreground with patches of mistbelt forest, and this occurs throughout the KwaZulu-Natal Midlands. And what these ecosystems and the previous one have in common is that they are invaded by invasive alien trees. And these invasive alien trees have negative impacts on water security of the region, fire risk, erosion, carbon sequestration, and biodiversity, resulting in damages up to millions of dollars every year. So we need to restore these ecosystems for climate change adaptation by clearing invasive alien trees, as the yellow arrow shows on the right. But managing invasions requires accurate and up-to-date maps for prioritization and costing. And many data-scarce regions simply don't have these maps, and when they do, they're hopelessly out of date. So as you can see, if it's green, it's not always good. So to solve the challenge, we are exploring the potential of mapping these alien trees in various African ecosystems using freely available imagery. And we do this so that we can allow repeatability in under-resourced regions. On the right-hand side, I'm showing some of these maps and some of the key land cover types I've pulled out on the left so that you can watch these. The current map shows the Umgeni catchment in KwaZulu-Natal. So our approach involved very detailed collection of ground truthing data. So we take a strong ecological approach, getting down into the field, and we collect data for around about 15 classes. And we use free platforms, in this case, Google Earth Engine and free imagery. And we also do ground truthing. On the right-hand side, you can see the city of Pietermaritzburg and its invasions. And the last set of maps is of Fynbos in 2018 and 2020, where you can see that the alien trees have really been invading. And we get really good accuracies of over 85% for overall and over 80% for telling these alien trees apart. And you can read more about this in 2 papers that we've published. So why is this important? Well, these maps can be used by managers, landowners, and NPOs, and be used for everything from planning to costing and also raising awareness. So here is a case study of the Friends of Takai Park who are using this for alien clearing and raising awareness on the ground. And we really hope that the method that has been developed can be used by other under-resourced regions for alien clearing. And you can get all of these resources here by these links. And thank you to all the people involved.
Thank you for that wonderful talk. I think this is a wonderful example of what you can do with satellite and drone imagery on mapping of alien and invasive trees. And it's surprising how badly invaded these ecosystems seem to have become. And with the approach on with involving lots of ground truthing and delivering high accuracy as a result, do you foresee technologies like hyperspectral data for alien tree species identification and other novel techniques being promising for scaling up some of your research?
Yeah, so that's a great question. Thank you. I think that we would absolutely love to use hyperspectral imagery. It would allow us to do so much more detail. And at the moment, our maps are limited by the spectral resolution. So that would be great. However, we are very passionate about using freely available imagery and software so that our method can be used and replicated. We have this vision of living maps that can be frequently updated and by anyone. And so if at some point hyperspectral imagery is going to be made available on Google Earth Engine, we would love to use it.
Excellent response. All right, so let's move on to our second talk. There we are. Amanda Stahl, Amanda Stahl, I'm sorry, I've been pronouncing your name wrong. Amanda Stahl is a postdoc at Washington State University School of the Environment. She analyzes natural and social aspects of landscapes to identify promising approaches to conservation problems at site to large landscape scales. Let's hear her talk.
Thank you. Today I'll talk a little bit about adding satellite data to the toolbox of conservation professionals with Earth Engine. Agricultural lands are a critical component of conservation worldwide. For example, governments and conservation organizations aim to conserve 30% of lands by 2030 to save nature. To achieve such goals, national to global conservation portfolios need to include privately owned working lands. Programs that involve private landowners would benefit from more dynamic access to satellite data at appropriate scales to track gain and loss through time. Existing data could then fill information gaps for planning and monitoring conservation actions. However, satellite data hasn't really been accessible to the local organizations with conservation professionals that coordinate and monitor private conservation measures. Aiming to fill this gap, we developed a method for cloud-based environmental monitoring with Earth Engine. Our goal is to develop image analysis methods that can support groups with varying capacity in terms of funding or technical capabilities. Our approach is to partner with conservation districts, the local organizations that work with private landowners, to develop methods that meet their current needs. We develop scripts and apps in Earth Engine, and we plan to transfer the capability to professionals for ongoing use and development so that they can interact with the data and ask questions as they arise. We drew some recommended steps from our study for broader applicability in other settings. These include developing questions that fit both the needs and existing data, to take the time to educate professionals and seek their feedback throughout the process, and to work together to identify and navigate barriers and opportunities to implementation in existing programs and strategies. This map is an example output from our study, and it shows areas of natural vegetation in green or areas of change in magenta or pink from 2016 to 2019. The areas of change are due to either weather patterns or human actions. Conservation districts are already using products of this analysis and have included them in their 2020 monitoring reports to our state of Washington in the US. We're currently transferring capability to conservation professionals in a couple of ways. First, we're developing a series of prototype apps linked here with scripts and documentation available and updated on GitHub. We've also written an article coming out soon in the journal Bioscience about cloud-based environmental monitoring and how to go about adapting this approach to fit an array of applications. Please feel welcome to contact me by email with any questions or to follow up on this presentation. Thank you very much for the opportunity to share our work today.
Thank you for your excellent talk and your excellent work. You mentioned that the vegetation change data are already being used by the state of Washington for their monitoring reports. We get really excited when we see a lot of these Earth Engine analyses getting applied in the public policy space. And so I was wondering if you could elaborate a little bit more on how these data are being used in specific policy actions, if they are, and also whether the data are informing national 30 by 30 targets outlined by the Biden and Harris administration.
Thanks for asking. First, I'll say in Washington State, there's a relatively new program called the Voluntary Stewardship Program. And this is an attempt to enable agricultural counties to opt in. And when they do opt into the program, then they can use voluntary measures, report on how they are working to maintain and enhance ecosystems in agricultural areas, and thus avoid direct regulatory oversight. So it's something that's very appealing from the agricultural perspective, but can be difficult to monitor. And so the state is requiring that for counties to satisfy the requirements, they have to find a way to demonstrate how the ecosystems are doing and to show that voluntary measures are working while protecting landowner privacy. And so this means reporting at watershed or county scales. And so we worked with 3 counties to help develop their monitoring strategy. The first reporting cycle for this program happened last fall. And we worked with 3 counties to derive area-based data on natural vegetation cover, and how that intersects with agricultural areas and how the floodplains next to streams are doing in those counties. And so that has established a strategy that we hope to continue developing going forward, and other counties have expressed interest as well. As far as the 30 by 30, we are currently outlining our next research steps. So the answer is not yet, but we are hoping and planning to build a collaboration network with conservation organizations and government agencies so we can start to develop the different applications that would help support both prioritization and accounting for 30 by 30.
Excellent. That's really exciting work. I also want to make a plug to our audience members. If you have any questions yourselves you'd like to ask of the audience members, remember there's our Q&A section at the bottom of the screen where you can type in your own questions. So let's move on to our next talk. We're being joined also by Matt Hepler. Let's get him on the screen. I'll give an intro while we're getting him. There we are. Hi, Matt.
Hello.
So Matt Hepler is an environmental scientist at Appalachian Voices. He has been working with community members dealing with issues related to mountaintop removal for coal mining, specific lawsuit development or mining policy. Recently, he's been using remote sensing to classify restoration and recovery of former coal surface mines. It's great work. Let's hear his talk.
Hello, everybody. My name is Matthew Hepler. I'm an environmental scientist with Appalachian Voices. I want to present to you today the Central Appalachian Mine Reforestation Assessment Tool. This is a project partnership with SkyTruth, 4E Analytics, Green Forest Works, and Downstream Strategies. I also want to give a special thanks to National Geographic for helping to fund this project. Our tool is looking at reforestation on mine sites in Central Appalachia. It's based off of previous work we did, Appalachian Voices did with SkyTruth and Duke University, characterizing active mine lands using satellite imagery. Now here we see the Hobet mine in West Virginia, and you can get a sense of how mining and reclamation happens. This mine is owned by Environmental Resource Partners, And you can kind of see the active mine going, and then it fades to shades of green and then darker green as reclamation happens over the course of the mining cycle. So we wanted to look at these individual mine sites and start characterizing reforestation and recovery using mining indices. We even created one called the aggregated recovery metric, and our algorithm spit out a table of 35 years worth of these various indices to tell how well a mine site is recovering. Most of these mine sites fit kind of the pattern shown on the graph above, with a pre-mining section, a section that shows a steep decline where mining is happening, and then this post-mining recovery period that happens slowly over time. We looked at our data and we compared it to state inspectors' data that go out on mine sites and characterize both the disturbed land and the land that is reclaimed. We used a benchmark of 70% on our aggregated recovery metric to justify or say that was a meaningful benchmark for hitting a state of recovery. And then we compared that to the state's data. So looking at that, you can download our data at the SkyTruth website along with our original active mining data as well. Here you can download shapefiles, GeoJSONs, and 2 versions of our algorithm. You can also download our report on the Appalachian Voices website, where you can learn more about some of our other findings related to this project, and also look at a web map. As for next steps, one of the important things we're working on right now is looking at trends in the data and using that to assess the mine sites. So kind of characterizing sites that are not recovering as well versus sites that are recovering faster, and looking at the differences in mining practices between those 2 sites.
Excellent. Thank you, Matthew. My question was, what are some of the challenges of advising companies on their restoration efforts? And do you see a lot of these active landscape restoration efforts or reclamation efforts taking place across the wide swath and the wide variety of mines that Appalachian Voices studies? Or is it sort of narrow into, is it a small number of mines that are really doing active restoration on the landscape?
Yeah, well, we did look at a comparison between 2 specific mining styles or reclamation styles. One called the forestry reclamation approach, which is kind of a newer method of recovery versus a older method which compacted the soil more. And we did find that some of the forestry reclamation approach sites actually did a lot better in terms of years to recovery and how well they did in reforesting the land more quickly. In terms of, we actually don't work with mining companies directly, but we do hope to influence policy with some of this data.
Makes sense. Excellent. So we'd like to move on to our 4th talk by Tanushree Biswas. Dr. Tanushree Biswas is an applied remote sensing and landscape scientist. At Nature Conservancy, she uses advanced satellite remote sensing technology, data mining, ML, big data approach, and open source platforms like Earth Engine to develop tools and solutions and demonstrate how nature can play a significant role in climate mitigation by reducing greenhouse gas emissions while benefiting people and climate. So she wears a big hat. Let's hear her talk.
Thanks, Tanya. So today I'm going to talk about a study that I led with my colleagues and co-authors on systematic assessment of tree cover inequality in US cities. Urban trees provide shade and provide many ecosystem services to its residents. As climate change continues to grow and impact our lives, cities are not removed from that impact. Temperatures are cooler during hot summer under trees, which benefits people. However, studies have shown that there is a disparity in tree cover across multiple cities. We wanted to see if there is a way to systematically assess the tree cover disparity across multiple cities over time. And who benefits from this tree cover? We used Google Earth Engine to map tree cover at 2-meter resolution using machine learning approaches, available free data set across 5,000 US cities. This data set was then rolled up at census block group level to look at the spatial variability of tree cover. The panel on the right corner shows the tree cover variability, followed by assessment of surface temperature from Landsat data. When that was paired with census block level assessment of income, we see a clear spatial pattern of variability in tree cover. It clearly shows that poor neighborhoods had less tree cover and hence experienced hotter summer and more heat stress. And the pattern is consistent across all the cities we studied. In 92% of US cities, urban tree cover was 15.2% lower in the low income group than the higher income group, and they were 1.5 degrees hotter. This variability in tree cover between high and low income communities we call as tree gap. A total of $17.6 billion investment is needed to address this disparity if we want to address climate change on ground and bring solutions. This would benefit 42 million people who live in those neighborhoods. We took that data set and did a deeper dive in Los Angeles and found that this could save 1,000 lives over 10 years. Our study clearly demonstrates at how technology and big data today can be paired with science to address big problems and issues on social equity and climate change. All this data set is available through our app, the Urban Tree Inequality Atlas, to explore the variability in tree cover, and the panel on the right shows the areas where you can close the tree gap across all US cities that were sampled. It is time to act now and explore solutions by combining technology, science. And with that, I would like to thank all of you presenting our vision to call to action that we need to work towards bringing natural climate solutions to urban areas by addressing social equity through urban afforestation, and benefiting communities to address climate change.
Thank you, Tanushree. I guess my question here for you is around, there's citywide tree planting efforts, right? Which seems to be the majority of the work that we've looked at. But there's also private landowners who make daily decisions about their own landscape. And so in addition to sort of funding tree planting efforts, do you see opportunities at all to change laws around removal of urban trees on private landowners' property? It might not be so much in this area, but I think this is somewhat could be complementary. There are heritage tree regulations in the US, but it's possible they don't go far enough. And I guess how does society account for this sort of balance around private landowner laws, the cost of avoiding tree removal while valuing what trees provide to people?
That's a great question, Tanya. And I think those are exactly the type of opportunities we want people to start exploring with this kind of results and data set, because we did at census block group level, which means we looked at people's houses, not individual people's houses, but within a census block group. If it is an residential area, we are able to see what is the tree gap. And the deep dive that we did in LA actually looks into it exactly that and sees what is the available opportunity for tree plantation and how that can reduce urban heat island effect. So that's the space that is available. And then your next question was on laws and policies, and that's where those are the directions and boundaries we want to push. We want to really see that how we can encourage and incentivize communities, local communities, how homeowners to really take action by increasing tree cover in their neighborhood, and encourage legislators and politicians to really bring in tree cover back into communities which have been deprived. So that's the space I think we need to explore with a strategic, intentional vision if we want to talk about reducing climate impact in cities where the vulnerable communities are more exposed. So that's exactly our vision, that we hope this kind of conversation comes up and we start looking into what policies we need to change, what laws we need to bring in to make the difference.
That's excellent. That's yeah. I look forward to the effect of some of your work in my own local area because I think there's a lot of need for it. Our next speaker is Laura Poggio. She is a digital soil mapping specialist at ISRIC World Soil Information. Laura's main research activities aim to address the role of key natural resources that are supporting ecosystem services. Her work is based on spatial and geostatistical modeling and integration of environmental data at different spatial scales, especially remote sensing and ground data for digital soil mapping. Let's hear from Laura now.
Today I'm going to talk about global soil information can be used in support of nature conservation and why. Soil is at the center of many ecosystem services and it delivers services that enable life on Earth. Soil is fundamental for things like soil security, food security, but also water security, biodiversity, climate change, and ultimately human health. In order to obtain map of soil information, an approach called digital soil mapping is often used. Digital soil mapping links soil profile measurement or ground data with environmental covariate or ancillary data. These are often derived from remote sensing products, and they represent the soil forming factors such as climate, vegetation, or morphology. Using geostatistical machine learning or artificial intelligence model and computational power, we can therefore obtain maps of soil properties. A global product that uses DSM in order to obtain soil property maps is SoilGrid as produced by ISRIC. It has 5 prediction layers. It has both the central prediction and uncertainty because these models are uncertain and this information should be made available to the users. As soil is a 3D body, the information is not only available for the surface but also for various deep layers. Primary soil property are available like pH, nitrogen, or organic carbon that allows other that can be used in other models like hydrological model, climate model, crop yield, or biomass productivity. However, these soil property maps are a bit difficult to interpret. So there is the need for maps for actionable information for stakeholder, NGOs, or policymaker to translate soil property in soil functional mapping, to produce layers like erosion risk or carbon sequestration potential or potential for various crop growth. This feeds in the concept of soil security that matches the ideas of food and water security for the soil. In summary, SoilGrid is an example of existing legacy data to create a baseline. Can and should be integrated with local and national products to improve accuracy. From these basic primary soil product, functional maps can be derived to identify areas for potential management intervention, and this is particularly important in the context of sustainable development for climate change and preservation of our planet. Remote sensing data as derived from Google Earth Engine are fundamental for soil assessment and digital soil mapping. And finally, SoilGrid can be found on Google Earth Engine to be further used in other modeling. Thank you for your attention, and I am happy to answer any question that you have.
Thank you very much, Laura. Global food security, as you clearly illustrated, depends on healthy soil. And with Soil Grids 2.0, we now have a globally available soil data set to help us plan and predict this food security into the future. So what's next? What are with this rapidly evolving interest in regenerative agriculture and so forth? How do you see the study of soil health improving?
Hi, Tanya, thanks for the question. This is a really interesting topic of discussion because food security is really important and soil health is becoming a concept that is more and more studied and more important with slightly different definitions in different countries. For me, it's important to point out that SoilGrid provide a general information at global level, but if you really want to provide information for the stakeholder and the decision making at local level, you really need to integrate this with field data, possibly we saw drone or hyperspectral or high resolution remote sensing data. And this is really important because the difference between global and local scale is fundamental, especially for food security and soil health. And further development in soil health, beside the spatial model and the input data, is also to come with more functional definition of that. So not only limit ourselves to the content of carbon, for example, but really trying to model and understand how the soil works and how the soil provide the services that that we have and that we need. Thanks.
Excellent, thank you, and wonderful work. Before we go to our last and final talk by Dan Dixon, I want to make one more plug to the audience watching that you can answer or ask questions in the Q&A section below the screen. Feel free to input any questions to any of the speakers who we have today. So our last talk is Dan Dixon. He is a PhD student in the School of Agriculture and Environment at the University of Western Australia. His research is funded by the Cooperative Research Centre for Honeybee Products. His research looks at landscape drivers of eucalypt forest phenology in Southwest Australia. The results will inform forest management efforts, biodiversity conservation, and the beekeeping industry, which greatly relies on flowering resources. Let's hear more about Dan's work.
Hi, I'm excited to share how we're using remote sensing and Google Earth Engine to study forest phenology in Southwest Australia. The study of phenology looks at the timing of plant life cycle events, and flowering is a crucial step in that process. Flowering is a bioindicator of forest health, but it also provides resources for birds, insects, mammals, and the production of honey. Our focus is on the eucalypt forest species Corymbia calophylla, or Mary, of the Northern Jarrah Forest, a biodiversity hotspot of Southwest Australia. These trees synchronize their production of cream-colored flowers each summer, but vary year to year. And broadly, its relationships with climate and fire are poorly understood. So our aim is to first build tools to measure these flowering events over large areas, and second, to better understand their environmental drivers. From above, you can see how the forest goes through this transformation, but some trees flower late and others not at all. So we needed a model that could capture the spatial and temporal variation at the individual tree crown scale. The model we created was just published in the journal Remote Sensing of Environment. It uses two sets of data. First, the PlanetScope time series, which provides near daily satellite imagery with 4 bands at 3-meter spatial resolution. From this, we generate a greenness index and a brightness index, where during flowering, we see a decrease in greenness and an increase in brightness. Next, we captured a series of drone images to inform each satellite pixel of its flowering quantity on different dates. And using a machine learning model, we generate a flowering prediction over time. And most recently, the accuracy of our model for predicting full flowering crowns is around 80%. We rely greatly on the geospatial tools provided by Google Earth Engine, really from start to finish, which includes cloud masking, resampling, filtering our time series, extracting predictor variables, and then training and predicting of the model. And now I've put together a slide to visualize our results over time. I've zoomed into a protected forest reserve where we map flowering probability and over time. And the chart shows the count of flowering pixels between January and March 2020. We see the event lasts no more than 3 weeks and is largely concentrated in this riparian zone in the center of the map. So with these data, we're working to scale our model across the landscape and include multiple years to better understand the effects of climate, fire, and topographic position on flowering. And these findings will be useful for forest managers, conservation efforts, researchers, and beekeepers who directly rely on forests for their livelihoods. Thank you.
Excellent, Dan. Thanks so much for your presentation. With these flowering events that you showed being in a very small, very narrow 3-week window, and in this right corner, I guess, do you see fire events changing that, or is that something that you'll see when you scale up to larger study areas? That was sort of the first part of my question. I guess that sort of lends itself to, like, how do you see this methodology scaling up to other regions?
Well, thanks, Sonny. These are good questions. So yeah, these are some of the broad landscape scale questions that we're trying to ask. And first, we had to build this flower monitoring tool with the satellite data. And you're right, it happens only over a period of a few weeks, but there's some benefits here for pollinators in that there's a wide diversity of species. So maybe one tree may be flowering at one time of the year, but you go a month before or a month later, and you can have a totally different flowering species. And in terms of fire, it's really not well understood how fire events and fire of different severity, so really the impact to the crown, how that's going to influence maybe the timing until the next flowering event. And here in the southwest of Australia, each block of forest is getting burnt between every 5 and 10 years, whether it's through wildfire or prescribed burns, like fuel reduction controlled burns. And so yeah, these are some of the questions about the severity of a fire, and then the time since that fire, and how what is the likelihood of and the timing of expecting flowering events in the future from that fire. And then in terms of scaling up to the larger landscape scale, some of the challenges. First, we rely on PlanetScope from Planet Labs, and this is not freely available. So we're trying to get our hands on as much PlanetScope imagery as possible. And also knowing where to look, because there are so many different species here, it's actually difficult because we're trying to zoom in on a specific time of the year. And because there's so many different types of trees, we don't actually have great species level data. So that'll be something that we continue working on and trying to figure out when and where we see these events. So yep.
Yeah, excellent. There's and there is sort of a lot of interesting work going on in the individual tree species identification world. But it sounds like something like that could really benefit the work that you're doing on the ground as well. Excellent. Yeah. Thank you. So let's, well, first of all, thanks everybody for your wonderful talks. It's really, really inspiring. It's great to see how people are using Google Earth Engine and other technologies. A lot of people using drones for ground data in novel ways. So yes, let's welcome everybody back on the screen, and let's take a look at Q&A from the audience. We've got some really good questions coming in already, and feel free to keep more of your questions coming. So our first question from the audience is from Alanna. What has been key to achieving tree species level classification from free satellite imagery in your area? For example, is it using multi-dates for phenology, using specific bands like red edge, or something else?
Thanks.
That was for Alanna.
Yeah, thanks. That's a great question. So we've explored quite a few different methods to try and see what the best approach would be. So one of the things we tried was different algorithms. So looking at comparing random forest and SVM and so on. And we settled on SVM for our particular African ecosystems. And then we also tried looking at data fusion. So we tried to use Sentinel-1 as well as some topographic information as well from the ALOS data sets. So that was really interesting. And for some of our ecosystems, data fusion improved accuracy, but only slightly. And for other ecosystems, it actually didn't. Sentinel-2 was still the best for predicting vegetation. So the other thing that we did, we looked at feature selection as well. So we used, I think, around 40 different indices. And we added that to the classifications to try and see whether these indices like NDVI and 40 different indices, whether any of these improved the results. And then we used feature selection to select which of these would be the most useful. And we actually found that feature selection wasn't helpful. Perhaps that's a bit of a no-brainer, but including as much information as possible gave the best results.
Excellent. Thank you, Alanna. And Tanushree, did you have something you wanted to add as well on tree species? Okay, good. So the next question is for Amanda from our speaker, Alanna. It seems you are mapping ecosystem change, which may be due to climatic variations or actual land cover change. When the county landowners get this information, what's the impact on the ground? Does it change behavior or translate into protecting the environment? And actually, Alanna, if you wanted to expand on any of that yourself and ask the question in your own words, then please feel free.
Great, that's perfect.
Thanks for the question. So first, I'd like to say that we were also working with Sentinel-2 imagery, which has about 10-meter resolution. And many of the areas that we're focusing on could be these narrow strips of riparian vegetation that are only maybe 30 feet wide. And so the study that I was showing the outcome from was really focused on this broader scale watershed or county level detection, and then highlighting those areas that were in pink in the map that were areas of change. And then what we would need to do is ground truth within those areas. And so we started as part of this initial study. We did a pilot study with drone imagery, sampling different areas around the county and trying to get a handle on both what's happening with individual species within those green areas, and also trying to start developing ways to evaluate and show what's happening in different areas at finer resolution. So we're partnering with conservation district staff who are on the ground all the time, and they are really interested in helping us to ground truth these areas, but also targeting areas for outreach, because they can connect with more landowners. If we see there's an area that's showing a lot of drought stress with climate change or something like that, then they can try to help get them connected with funding sources to do restoration, for example, along streams.
Awesome.
Excellent, thank you. Our audience member, Jordy, says, congratulations to Dr. Biswas. Really interesting study and national coverage. Has there been a similar study for any Mexican city?
I have not seen any paper that has talked about a similar study in Mexico, but we hope something similar can be done globally in other international cities and countries.
Yeah, I agree. It'd be lovely to see that work scale up. It's excellent, excellent work. The next question is for Laura. At what resolution is it possible to map soils using your techniques?
Thanks for the question. That depends on a lot of things. That depends on your input data, how dense and how representative they are. Depends on your remote sensing images, so which one you are using. And it depends on the accuracy and the purpose of the models. For these techniques, there are examples that go from precision agriculture, so few meters, to global study. In the case of Solgris, it's 250 meters, but there are other continental case at 100 meters or global case at 1 or 5 kilometers. So it really depends, and we have to pay attention that higher resolution, finer resolution doesn't always mean a better model. It's just that we really need to look at that from the input data point of view. So I cannot give a precise number. It really depends on a lot of the input factors.
Excellent, okay. Our next question is for Alanna from Amanda. Amanda, would you like to ask your question live?
Oh, sure. I don't remember exactly how I worded it. But my question was basically, what advice would you have? For example, we get a lot of questions about weeds and noxious species and how can we distinguish those from satellite imagery. So I was just curious, if you were starting all over in a new place, what advice would you have for figuring out what models to test, what indices to test, or how to do your field sampling for ground truthing?
Thanks. That's a great question. So, I mean, if you were using Sentinel-2 imagery, which I'm going to assume, we worked at a 20-meter resolution because we found the red edge bands most useful for discrimination of different vegetation types. So 20-meter spatial resolution is really big. It's quite coarse. So the advice I would give is to keep it simple. For that kind of resolution. And we used about 15 different categories. So one could stick with that sort of ballpark and sort of group aliens into categories. So not looking at individual species so much as perhaps genera. And I think in terms of local advice, I think that it is so critical to consult local ecologists. I think often ecologists are really sidelined. Whenever there's an engineering problem, you look for engineers. Whenever there's, a technical problem, you look for technicians. But when there's an ecological problem, suddenly everyone's an expert. And I think it's really critical to consult local ecologists and get their advice to make sure that it makes sense and it's going to yield useful results.
Thank you.
Great. We have another interesting question for all the speakers. We'll have to do a roundtable from Dave Thau in the audience. Hi, Dave. His question is, how do you all deliver your results to end users and decision makers who can take actions based on your data? Is Earth Engine useful for that, or do you move to other methods? So anybody want to take a first crack at that, and we'll go and ask anybody who else wants to comment.
I'll jump in.
Great.
I really enjoy the apps, and I find them very powerful tools for communicating. So and that's the Google Earth Engine apps, where you can do sliders to show comparisons. It's just been so impactful. So both showing different dates in time and changes in land cover, but also looking at specific events. So for example, when we had a fire in Cape Town, mapping the fire scar and overlaying invasive alien trees on that. So that's been really cool for us.
Yeah, and I would like to jump in as well. The reason our work took such a big got such big attention is because we were able to spatially show that the disparity is not just within 10 cities, 5 cities, across 5,000 cities. So it's a big consistent problem that needs to be set. And the Google Earth Engine apps are just the tool that has come to our use that we can communicate that with decision makers. So it's very, very useful. Tanya, there was one question in the chat on urban and grassland ecosystem. Can I take that, or are we short on time?
Yeah, I think we have a moment. Let's just see if anybody else has any comment. We'll switch to that in a second. If anybody else has anything to say about delivering your data to decision makers. Anybody else want to jump in? Laura?
I can say that Google Earth Engine is a fantastic tool for that. As been said, the apps are really useful, but just the option now to upload our own assets to Google Earth Engine and allow other people to use them, I think that is really useful, and that will make things much easier for also providing answers to policymakers.
Excellent. Dan or Amanda, did you have anything else to add?
I can add something. Just our specific case of how we're trying to share all the data that we're kind of processing. So, beekeepers are folks who, they really rely on forest phenology for their livelihoods, but they're rarely being able to look at the landscape from such a large scale perspective. They're looking at individual trees, or they're just, driving, for kilometers and just making observations. So really trying to work with them and come up with ways to spatialize all this data and make, with the apps, it's so easy for anybody who really just has a computer and a web browser to automatically be able to visualize some very complicated data and products just with a few clicks. And you scroll in and out, and you can zoom into your very specific region of interest. So I kind of echo what everyone else has said about apps are fascinating, and still trying to come up with unique ways to use the tools. So yeah.
Excellent. Amanda, did you have one? Did I see your hand go up, or was that from before?
I did have something to add. I agree that the apps are really powerful and they are great for a certain subset of our end users. But something else we've really been trying to do and have heard a lot of interest in is actually transferring some of the scripting capabilities to organizations that do have GIS expertise but haven't made the leap into Earth Engine yet. And so we are kind of providing guidance for different organizations through that. And that's what our recently accepted paper is also trying to do, is really expand the users of Earth Engine, because that would enable people to interact with the data, not just what we envision and put in an app, but also beyond that to experiment with it.
Oh, that's excellent. That's really, that's music to my ears. That sounds really awesome. Need to explore. So Tanushree, let's move to you now. From our speaker Alanna. Alanna, would you like to ask your question directly?
Sure. So basically, I'm just maybe playing devil's advocate a little bit here, but so there are many ecosystems in the world that don't have trees. So for example, desert ecosystems, but perhaps less extreme, we also have shrublands. So I grew up in Mediterranean shrublands, the fynbos biome. And then we also have vast areas of grassland and savanna. So my question is, urban areas in these regions, does a lack of tree cover really indicate that there's something wrong? Indigenous people in these areas have lived without trees for a long time, and they've have local adaptations to that. And I'm not saying that that you're the only group that's looked at this. We've had a paper published in South Africa called "The Green Apartheid," looking at Cape Town and looking at how the wealthier areas are very treed up and the less wealthy areas are very bare in terms of trees. But it kind of ignores the soil types and what these soil types can support, because the poor areas in Cape Town are also on sandier soils that have less nutrients and don't hold water. So there's all of these complicating factors. And so I was just wondering what your thoughts are on this. In South Africa, we fight very hard against this perception that trees are always good. It does a lot of damage. These global indiscriminate tree planting initiatives can be very dangerous, and we're fighting hard to protect our indigenous ecosystems from being planted up by Europeans as part of the Bonn Initiative, for example. So what are your thoughts on that?
I completely agree, Alanna. I think taking into account the local climate and taking into account of the local ecology is very important. Depending on it's also important to pay attention to what species are you planting. Are you planting exotic species or native species? That's why we call our project urban afforestation, not reforestation, because it could be that there was no trees or forest in those cities. Like in the national level analysis, Phoenix was one of the cities, and we had exactly the same problem there. So when we are talking about urban afforestation in Phoenix, it has to be desert species and also has to be taken into account the ecology. So that's absolutely required. But we were talking in terms of reducing urban heat island and the temperatures. Like you said, it's a complex process, and it's not one method, one formula that solves it all. But it needs to be looked at from the ecology and the history and the future climate that is coming to that city. How does all of that respond? So, and I'm aware of the green apartheid paper that I did cite it in my study. So yes. And on the Google Apps, Tanya, there was another thing I wanted to add, that all while we are able to, like the complex analysis we all do, we are able to serve it to more clients through the apps, and they're also available on phone. But sometimes we have to, in my experience, in some other projects, we had to move away from the Google app because it didn't provide a way for people who are not into coding to interface easily, like downloading data set or uploading assets. So those are some new tools, if that could be added on the app side of it, so that people don't need to know they don't need to go to the GitHub code to download everything. Those will be something very useful that, administrators or a politician or a policymaker just draw a polygon and download only that section. So this is something I have been wanting to communicate. I think this is a great platform to share that. Having that flexibility on the apps side will be pretty awesome.
Yeah, that's great feedback, and we can also follow up offline and dive into some of those that feature request as well. So our last question today is from the audience. I'm curious to hear from any of you what you would think would make the biggest difference translating and scaling your approaches to see conservation impact into Newstream. Maybe this is exactly is a good segue to what you're suggesting. Is it better to have freely available data and tools, public and policy awareness across findings, resources being put to more studies like this? So anyone want to take a first crack at that?
I can take a first crack at that. I'll be short since I've been talking. I think that's exactly what we are hoping from our urban work. Like if we have access to free, higher resolution data set of, like NAEP is only for US. If we have a similar data set across the world, the algorithm is already there, the script is already there, it would just mean expanding it. So Google Earth Engine provides us the platform to scale up our algorithm, but we are limited in terms of high resolution imagery. So if some way that can be tackled, I think a lot of our conservation problems can be very easily expanded to other areas, other countries, resource poor countries. So
the input that I would give on that question would be that, scaling up is great and it's important, but oftentimes, and Laura mentioned this as well, as soon as you want to work at a local scale, you really need local knowledge and you need field data. So it's all very well having global models, but we have to be extremely careful about how applicable those are at the local level. So I would just add that word of caution as well. You always need local ecologists to translate this global information and downscale it really.
Mm-hmm.
Yeah,
if I can add to this, that I fully agree, but it's also you need local information, local data, and then a local high resolution image are great, that's for sure. But for me, it's also important to try to process and to try to pass on the message that at different scale you need probably different approaches.
Mm-hmm. And just something to add on top of all of that. Well, although I feel like we're entering to a stage where there's not going to be a shortage of data. We're actually having so much data, and really one of the challenges is defining clear stories and digestible, nice little nuggets of sharing that information, and that's so maybe policymakers or folks who are directly involved, they can cite that information, maybe just in their meeting with whomever. So yeah, really translating all of this big data into nice little stories. Something kind of like a Jupyter notebook type layout, where you maybe have like an introduction to some of the data, but on a very high level, maybe some of the analysis, but then really showing you the user or the way to visualize those results and what is the story and what are the takeaways, which is something that is hard to take away. It's hard to get from the apps, which are maps and products. But if someone doesn't know what they're looking for, obviously the people who created it, their eyes are trained to know exactly which pixels are supposed to do what. But for the folks who it's the first time that they've seen that data, they don't actually know. So the conversion of big data into nice little stories is something to add.
And underpinning all of that is the importance of freely available and open licensing to allow investigations into data so that when people have further questions, they can dive into the data source itself. Any other thoughts on that question? All right, lovely. Well, again, thank you for joining today's session. A special thank you to all of our speakers here for presenting. A couple of you staying up late in other time zones to join us. Thank you to the audience for our engaging questions to the speakers. Thanks to the speakers for your engaging questions to the other speakers. And we hope you're inspired or you got some fresh ideas to take to your own research. We also hope you tune in to one of our future Geo for Good events. We've got a number of trainings in the lead up for Geo for Good on MyMaps, on more on Earth Engine, some Google Earth, and more. Lastly, don't forget to register for our Geo for Good Summit happening in November, just 88 days away. So thanks again, everyone, and goodbye for now.
Thank you.
Thank you, Tanya.
Bye.
Bye.